How do these new characterization methods provide more detailed insights into the behavior of the electrolyte during battery operation, and why are they essential for advancing electrolyte research? Based on the results of these characterization techniques, what basic information such as chemical, electrochemical, and thermal stability can be obtained, and how does this data support theoretical studies in the field? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does the information gathered from these characterization methods inform the development of better electrolytes for sodium-ion batteries, and how does it help optimize battery performance? What is the importance of a comprehensive understanding of electrolyte and interface characterization for the advancement of energy storage technologies, and how does this knowledge contribute to designing more efficient and durable sodium-ion batteries? What are the primary focuses when characterizing and analyzing liquid electrolytes, and why is it important to examine both the components and electrochemical properties of the electrolyte? How does FTIR spectroscopy contribute to the study of the components of liquid electrolytes, and what specific role does it play in identifying the electrolyte's composition? How are different absorption wavelengths in FTIR spectroscopy related to the identification of organic functional groups within the electrolyte, and what does each specific band represent? What types of polar functional groups, such as carbonyl, C equals O, nitrile, C is identical to N, sulfonyl, S equals O, and ether bonds, O, are typically observed in FTIR spectra of electrolytes, and what information do these groups provide about the electrolyte's chemical structure? How does the presence of these polar functional groups affect the behavior of the electrolyte in electrochemical systems? How can Raman spectroscopy be used to study the solubility of solvents for sodium salts, and why is this important for understanding electrolyte performance? In what way does Raman spectroscopy help determine the coordination relationships between cations and solvent molecules, and how does this relationship influence the overall function of the electrolyte in energy storage systems? How do these characterization techniques, FTIR and Raman spectroscopy, complement each other, and what additional insights can they provide when used together for studying liquid electrolytes? What role do these characterization methods play in improving the development and optimization of electrolytes for various electrochemical applications, particularly in sodium-ion batteries? How can CV and linear sweep voltammetry, LSV, curves be used to study the electrochemical stable windows, ESW, of liquid electrolytes, and what role does this play in evaluating their performance? What information can be gained from EIS profiles of liquid electrolytes?